sure that I did that by hand though, just so you could see it. Alright, so now come the word problems. Don't let them intimidate you, okay? Here we go. The first one says, your school band is selling calendars as a fundraiser. Wall calendars cost $48 per case of 24. You sell them at $7 per calendar. Pocket calendars cost $30 per case of 40. You sell them at $3 per calendar. You make a profit of $120 per case of wall calendars and $90 per case of pocket calendars. If the band can buy no more than 1,000 total calendars and spend no more than $1,200, how can you maximize your profit if you sell every calendar? And what is that maximum profit? Okay, so this is a big time problem. Okay, first of all, let's go ahead and start with what equations are we going to have per se, as far as when we're building them. Alright, so let's look at the number of units, and let's look at wall calendars and pocket calendars. Okay, Daxton, what would you put for wall calendars on number of units? 24 what? Yeah, so the variable, you're right, would be 24x. Perfect. Yep. Skylar, what would you put for pocket calendars? 40 what? 40y. Yep, 40y. Alright, so let's go to Catherine. What would you put for the total of number of units? 1,000. Yes. So let's go to wall calendars. Riley, tell us, what is the cost of wall calendars? 48. Yep, 48x. Okay. Pocket calendars. Michael, let's go with pocket calendars cost. What would you write? 30y. And let's go with Corbin. What would you write as a total for the cost? 1,200. Yeah. Now let's go for profit. Thomas, what would you write for the profit for wall calendars? 120x. Okay. Tyson, what would you write for the profit for pocket calendars? 90y. X is the wall calendars, Y is the pocket calendars. And last but not least, let's go with Aaron. What would you write for the total profit equation? Help her out, Joel.
120x plus 90y.
Nice, yes. 120x plus 90y. No worries. This one takes a little bit of thinking about what are we actually adding together for that profit. Okay? So, now we got to decide equations of what we're going to build based off of what we just read. Okay? So let's build our first equation. Our first equation I want to build is the 24x and the 40y, the number of units. Okay? So let me move, now that we have that filled out, let me move down here and we're going to start building these equations. Alright, let's go with Brianna. What is the first equation with the number of units? Yes, 24x plus 40y. 24x. Or wait, my bad. What am I doing? 24x plus 40y. Brianna, finish it up. Is what? So not equals yet. Is less than or equal to 1,000. Santiago, why is it less than or equal to? Because they cannot buy more, but they can buy up to or less. Okay, perfect. Alright, so now we're going to go to another equation that we have involved. Nate, what would be another equation?
The cost would be 48x plus 30y.
48x plus 30y is less than or equal to 1200. So I have the number of items and I have the cost. Those are those two equations that we talked about last class that are very, very, very predominant. Any other equations, guys, that we could write out from what we have?
120x plus 90y.
20x plus 90y. 120x plus 90y, yep, is going to be our objective. 120x plus 90y. Because this equation is what we're trying to maximize. Right? You wouldn't want to minimize profit. If you owned a company, you're not going to want to minimize your profit. You're trying to maximize your profit. And you're trying to see what are all the different possibilities of intersections that occur so that you can see where your maximized profit will occur. Okay? Any other equations out there that we could build? There's two more. Yes? Go ahead, Thomas.
Shoot, y is greater than, oh wait, no, y is greater than or equal to 0, and x is greater than or equal to 0.
Okay, so x is greater than or equal to 0, and y is greater than or equal to 0. Okay, there's two more still. And then I'm going to show you which pieces we use and how we build it all together. Actually, it's a reduced form of it, and maybe you're not thinking of it like that. No worries. These are the four equations. The other ones were reduced forms of those two that we have. But no worries. These are it right here. Okay? Any questions from this? Yeah. Go ahead.
One of the other ones, maybe, for the number of cases, x plus y is less than or equal to 250.
Okay. Close on that regard. No worries. Look at this. It says graph the constraints and shade to see the feasible region. All what they did here is they basically reduced a form of what you have in the first one. Let's say we reduced the first equation by dividing everything by 8. What would you get? 3x plus 5y is less than or equal to what? 125, right? So that one's our first one. And let's say we divided the next one by, let's say, 6. Okay? If I divided the next one by 6, what would I get? 8x plus 5y is less than or equal to 200. So these are just reduced forms, basically, of what you have here, so it's easier to see what the line looks like, per se. You see what I'm saying? It's just like a scale factor. Yes, Brianna?
Is there a reason why you divided it by 8 and 6?
So you could divide it by any number. I'm just trying to break them down to the smallest numbers so that you could see, like on a graph, easier. You see what I'm saying? It's still going to be the same line. It's just everything is multiplied down off of by factors. Okay, so we're trying to make the numbers easier. But yeah, we don't have to do this. We don't have to do this. You could graph it exactly how you wanted to, as far as what was in red. Okay? But another reason why you could see it, Brianna, is you could do elimination method by multiplying by a negative right there and solve what that x and y would be quickly. You'll see what her question was? She was saying, why did we bring those down so much? Let's say that I multiplied this by a negative 1. You can see now I'm going to be able to cancel out those y's whenever I find those intersections. Okay? Alright, so graphing these. X is greater than or equal to 0 is everything to the right of that graph. Or that line, my bad. Y is greater than or equal to 0 is everything that's above this horizontal line. And these equations over here will come from, or these two lines will come from those two equations. Okay, so let's get this one all by itself as far as y is equal to. Okay, so if I were to subtract the 24, I get get something that looks like this. And then if I were to divide everything by 40, I would get y is less than or equal to, let's go ahead and do, what's negative 24? And you can use your calculators for now for the instructional purpose. Put negative 24 over 40 and press enter. What does it give you as a reduced fraction? Negative what? 3 over 5? Okay, so what's 1,000 divided by 40? Say again? 25. And see, this is what we see. So Brianna's question was a big question, because right here at 25 is where my y-intercept is going to occur, and its slope is down 3 over 5, down 3 over 5. You know what I mean? So on and so forth. So that's how you see them going to the right, down 3 over 5, because what you would really graph would be this line right here. Okay? And you're shading everything.
Why is it the thing, the sign switch since you're dividing?
We never divided by a negative. Okay, so make sure that when you divide or multiply by negative, then the inequality flips. But if you don't, it stays as is. And yes, it would be everything underneath here, guys. Okay, just a reiteration. And then sure enough, if we solve for y on this equation here, we would get this line right here, and basically looking at everything to or below that function would be the less than. Okay, so our biggest points of interest are going to be at this corner, this corner, this corner, and this corner. Only the corners matter. Okay, only the corners matter. Alright, so let's label these corners. Let's say that we labeled it as, I know you can label it different, just like Nate was saying before, A, B, C, and D. What would A be? 0, 0. What would B? What's B? 25, 0. And I got that from looking at when does this cross the x-axis. In other words, y would have to be 0. So 1200 divided by 48 would give you 25, 0. Okay? And C. You're basically asking yourself, when do these two equal each other? And yes, you could put that into a calculator, menu 371, and you can solve that out. What do you get for C, guys, anyway? 15, 16. And last but not least, point D. That means I'm looking at this blue graph, and when x is 0, it will tell me what that value is. So anyone, what is that going to be? 0, 25. And now the last step, all I need to do is use this equation right here and plug in x is 0, y is 0. 25 is x, 0 is y. 15 is x, 16 is y, and then 0 is x, 25 is y. Okay? So for the first letter, A, what did P equal for A? 0. What did P equal for B? So if I put 25 as x and 0 as y, what would we get? 3,000. Nice speed on the calculator too. C. I'm using the calculator. I'm maximizing the profit. Anyone, what would I get for C?
3,000.
Yep, 3240. And last but not least, at D, anyone, what would I get? Yes, nice, 2250. So we're going to write down our maximum occurs, our maximum of profit is 3,200. So let's say max profit equals 3240 occurs at what? 1516. You could say this, or you could say occurs at x equals 15, y equals 16. But please don't say necessarily that it's at point C, from what Nate was talking about earlier, because we could label these different. Okay? And then the minimum. Obviously, where does the minimum profit occur, guys? 0, 0. Okay, and it's at or $0, and it occurs at x equals 0 and y is equal to 0. Okay,